Welcome to The Explainer. Today, we've got a story that literally rewrites the rules of algebra. Imagine a math problem that for 200 years, the smartest minds on the planet said was impossible to solve. Well, until now. So, for centuries, a huge chunk of algebra was built on this idea of a limit, a wall that mathematicians were convinced they could never, ever climb over. But here's the crazy thought. What if that wall wasn't real? What if this impossibility was just a massive 200-year-old misunderstanding? Okay, so let's get into it. The problem we're talking about is solving these really complex equations, high-degree polynomials. And for almost 2 centuries, the consensus was, nope, can't be done. Mathematicians really believed they had hit a brick wall, a point where exact answers just stopped existing.
Just take a look at this timeline. Back in 1824, the math world pretty much threw in the towel. They decided, okay, no exact solution exists. And for the next 200 years, what did they do? They used approximations. I mean, they were good guesses, sure, but they were never perfect. Then, boom, 2023, Professor Morad Sultan Ezouidi comes along and publishes a complete, exact solution. Just like that, a 200-year-old belief was shattered.
So you're probably wondering, why did they think it was impossible in the first place? Well, it all goes back to something called the Abel-Ruffini theorem. And the key, the absolute key, is in the fine print, using only radicals. Now, radicals are just your basic tools, right? Like square roots, cube roots, that kind of thing. The theorem didn't say it was impossible. It said it was impossible with only those tools. And guess what? That little detail turned out to be the whole problem. Okay, so why did everyone just stick with that belief for so long? What was it about the old school approach that led them right into a dead end? Let's dig into the limitations they were up against. And look, it wasn't because they weren't trying. The problem was the toolkit itself. That whole radicals only rule we just talked about, that was the first major hurdle. But then, as the equations got crazier, the number of terms just exploded. We're talking millions of terms, totally unmanageable. It got so bad that the community basically gave up, leading to this philosophical idea that, well, I guess this is just a hard limit of math itself. And that's where the modern breakthrough comes in. See, Professor Morad Sultan Ezouidi didn't just find some clever new trick. No, he came up with a completely different way of even thinking about the problem. This really gets to the heart of it. It's a clash of philosophies. You've got the classical view on one side, basically accepting that some problems are just born unsolvable. And then you have Ezouidi's view, which completely rejects that idea. He says, no, an exact solution has to exist for every single equation, period. And this chart just lays it all out. It's night and day. The old methods, they gave up after the 4th degree. Ezouidi's theorem, it's delivering exact answers for equations of the 20th degree and even higher. The old way was all about approximations, getting close enough. The new way is 100% algebraic, totally verifiable. Seriously, this isn't just a small update, it's a whole new ballgame. All right, so the theory sounds great, right? But how does it actually work? How do you take an equation that's been unsolvable for 200 years and, well, solve it? So let's meet the beast. This is a 20th degree polynomial. I mean, just look at it. The sheer number of moving parts, the complexity. With the old tools, finding an exact solution was just unthinkable. This is the kind of mathematical monster everyone thought you could only kind of tame with estimations, and estimations by their very nature are never perfect. But Ezouidi's method, it's just so elegant. Instead of a brute force search for some magic formula, it's smarter. It uses a recursive process, kind of like peeling an onion layer by layer. It reorganizes the whole equation into these manageable chunks. Then, it uses a series of clever algebraic tricks to pull the exact answers, the roots, right from the numbers already in the equation. In a way, it lets the polynomial solve itself. And the result of all that? 100% precision. The solution is totally algebraic, it's symbolic, it's exact. No more guessing, no more approximations. This moves us out of the close enough era of math and into an era of absolute, perfect certainty. Okay, so what are the big picture implications here? Because this discovery is so much bigger than just solving one kind of equation. It really changes how we think about what is and isn't possible in math. And this is really the mind-blowing part. The impossibility was never about the equation itself. It was about the limited toolkit they were using back in the 19th century. The problem wasn't truly unsolvable. It was just waiting for someone to invent a better tool.
You know, Professor Ezouidi really put it perfectly. He said his theorem expands the whole framework, proving that we can find exact answers for things the 19th century couldn't even dream of solving. It's about pushing the boundaries of what's possible.
So, for 2 whole centuries, there was this giant wall that everyone thought was the edge of the mathematical world. And now we know it was never really there. This breakthrough proves that no polynomial, no matter how complex, is truly unsolvable. And that just forces you to wonder, right? What other impossible problems are out there, just waiting for someone to look at them in a new way?